Hello everyone, you are welcome to my YouTube channel, Messed Up Mentors. In today's video, I will continue from where I stopped in video number 26, where I talked about introduction to plotting using Matplotlib. And then we looked at 2D plots, pie plots, 3D plot, but today we'll look at 2D scatter plots with randomly generated colors. And also other different plotting in Python. So here I will first of all import the package matplotlib.plt and also import the random package. And next I define a function which I call scatterplot with a default argument of number of colors as 20. And right inside the code here, I generate uh, randomly generate 20 colors. Okay, so I have a list of begin the random color with a pound or hash symbol, then have a random the choice of 0 to 9 A, B, C, D, F, which is like representing the hexadecimal number for colors for here I don't need the index, so I have it in range 6 because every color has a range of combination of 6 digits with letters. Okay, for so I also don't need an index in ranging colors. So for any number of colors, I randomly generate 20 or that same number of colors in the list. And next, what else I'll do next is that I will enumerate these colors for I and color in enumerate colors. Okay, all right, I would call plt.scatter. I'll plot a random dot rand int 0 and number of colors. In other words, I want to plot a random integer of number of colors, okay, ranging from 0 to the number of colors. And I also plot it against 0 to number of colors. In other words, my x and my y values, and I will define color for each of the plot, okay, of the points to be color, which is what I'm enumerating in this list of colors. And then I will choose the size to specify the point size as 20, and then I will show the plot. So right in here, if I run this code, what this means, you do understand that already. I'm using the global conditional, and then plots here, I'm plotting scatter of 10 plots. If I run this, what it returns, you see a scatter plot for just 10 plots. Okay, all right. It shows a scatter plot for 10 plots. If I run this next cell, I want a scatter of 100 plots. Run again, you see it gives me a scattered plot for 100 plots. Randomly generated colors for 100 plots. Likewise, you can run for 200 points. You also see again the randomly generated scatter plot for 200 points. You can see the y-axis and the x-axis, they match. It was for the random plot. So here we'll talk about plotting two or more y-axis. In other words, I want to plot multiple values. In other words, two y-axis against one common x-axis. So again, we import Matplotlib. We already have that in our namespace. I will import numpy as np because I want to generate the data. So next, I will create first what my x data, which in this case I'm using t. Okay, it becomes t dot x range, t dot np dot a range, generate random range of numbers beginning with 0.01 until 10.0 with an interval of 0.01. And then I'll call the first plot to be y equals np dot exponential t, and the second plot to be sine 2 pi t. Okay, so here will of course initiate figure and axis ax1, or you can use ax2, whichever one you prefer. So here I use ax1 first axis plt dot subplot, and then I will define the color to be red, and I'll call axis or set label. The time is in seconds. The font size, set y label y equals exponential t. Color is color because color is red here, and then the font size. And then next I will now plot t y1 and color equals color. I'll also set the tick parameters for the y-axis, and the label should be color. So for every tick parameter in the y-axis, if you take a color and then if you label that as the axis, uh, take the y-axis and label, each of the tick with that color. Then next, I'll define the second plot with choosing a color of green, and then I'll call ax2 and call ax1 dot twin x. In other words, I want a twin x-axis. that would instantiate a second axis that shares the same x axis with the first plot. So here our AX2 set the Y label, which is Y sine 2 by T. The R here using the raw string, okay, and then set the color and the font size, then plot Y and T and then Y2, setting color to color, and then set the tick parameters and label color should be color. So next I'll call fig.tight plot because here figure here has been instantiated as plt.subplot. And so we do this. Otherwise, if you don't have a tight layout, what happens is that the right Y label will be slightly clicked, okay, and then we show the plot. If we run this, what do we have? We have, oh, you can see the plot. So the first plot is in red and the second plot in green. So you see the first y-axis, the second y-axis with a common x-axis in time. So next we can do a log-log or a semi-log plot. How do we do that? Or also generate the x value, which is a t value, and the y value. I'm using the previous example, y1 and y2, to show this. So running this, I have this in my namespace to do a log-log plot, which is a plot a log of y against a log of x. You just do plt.log-log, ty1 color orange, label the x-axis, label the y-axis, and I will show the plot. If I run this, what we have, you can see a y label, x label, and you can, if you look at the axis, you see it is raised to the power of 10 raised to the power of 0, 1, 2. So it's a log plot here and a log plot on this side. Unlike previously here when we plotted y, remember, you see, and here also the plot remains the same, but the axes have been, you know, put into the log form, both x and y. Okay. Now, for semi-log, you can do semi-log y or semi-log x. In other words, you can have a normal y-axis and a log of the x-axis. So that's semi-log x. So to do that, just plot plt.semilog x and then passing t and y2. Here I'm using y2. You can use y1. It doesn't matter any of your y-axis. Okay, label the axis x and y and then show the plots. If we run this, what do we have? You see the semi-log plot here. The y-axis is a normal, labeled, but the x-axis is in log form. Remember, this is the y2. By plotting semi-log x, what does it give us? It gives us this plot. Okay. Next, we look at the semi-log y, and also here we use y1. So here we are trying to plot the semi-log of the y-axis, while the x-axis remains the same. Same, everything remains same, x, y, the label, and then all you need to do is just to change the call of the plot, which is this in this case semi-log y. So if you run this, what do we have? We see the semi-log y. For y1, it gives us this straight line plot. Let's see what semi-log y2 gives to us. If I change it to y2 and run again, look at what semi-log y2 gives to us. So y the x remains, the y2 is semi-log. So return that back to y1 and run again. It gives us a straight line. Unlike when we did a log plot of y1, gave us this curve, but when we did semi-log of y, we had a straight line. So here I'm just demonstrating the various plot that you can do, various 2D plots, the semi-log plot, the log plot. In the semi-log plot, we have semi-log x and semi-log y. Okay, you can look up the official documentation on Matplotlib using this link. I will leave a link to this note in the description box so that you can download this notebook and then you can also run this code. After doing following this video, you can do your own practice with the notebook. Lastly, before I end this video, I will talk about autocorrelation and cross-correlation plot. To do that, I will not dive more deep into autocorrelation and Y correlation here, but I would maybe in subsequent videos I would talk about autocorrelation laying the background and also the cross correlation plot. But here I'm just trying to show you how you can plot the autocorrelation plot and the cross correlation plot. So here we also have a figure and axis, and then we use AX to denote axis and call period of subplot. I want to have two subplots. Okay, in other words, 2 by 1. What that means is I have 2 rows and 1 column. So, and then I want to share the x axis. So, share x is set to true. So, they will share common x axis. So, if I have it this way, I can also index the axis by calling 0 and 1 because I have two rows. So, 0 and 1. So, 0 here, to plot the um, cross correlation plot, we use x call core, okay, in Matplotlib. So I'm doing cross correlation between Y1 and Y2. So I'll do Y1, Y2, use V lines, use vertical lines through maximum lag. I want it to be 50 because there should be a lag between the two data. Okay, and then normed value true, line width 2, and then color use red color. Then set the title as cross correlation of exponential t and sine 2 pi t, font size 14. Use grid true. Okay, if you don't want to use grid, you can set it to false. Then the next plot will be AX1. Here I want to do autocorrelation of Y2. Use V lines true, num true, maximum lag 50. You can also vary change this parameter to see how your plot, is displayed. Line with 2 here I'm using color K. K means refers to black color. Okay, set the title, autocorrelation of sine 2 pi t, font size is 14, use grid and plt.show. So if we run this cell, what do we have? You can see that in the first plot, the first subplot, we have cross correlation of A and T. It gives us this. That's the cross correlation. And in the second plot, we have the autocorrelation of sine 2 pi t. It gives us this. So this is just an example of how we can do cross correlation plot and autocorrelation plot. Likewise, you can decide to do autocorrelation plot of Y2. Here we did autocorrelation of what? Autocorrelation of Y2. So you can decide here to do autocorrelation of Y2, but in this case here, what I'm doing is I'm increasing the maximum lag to 100. In the previous plot, I use a maximum lag of 50. So for a maximum lag of 100, what do we have? You do that plot, you see the plot changes. Okay, I've used a blue color. So look at the maximum lag of 100. So there's a lot you can do with this. You can tweak each of those parameters based on your choice, and then you see the output of the plot. Let's look at annotating plots with legends. In all of this video, when you have more than one plot, we need to attach a legend to define each of these plots. So, and to do that, you need to use the legend keyword. So here I have my x-axis, which is the time, the t-value. Here I use np.linspace to generate a linearly spaced vector between 0 and 100 of it. And then y1 is 2 sine 2 pi t, and y2 is 4 sine 2 pi 2t. Okay, so it's like 4 sine 4 pi t. Okay, so here I just create a figure, an axis, plt.subplots. Okay, whenever I'm doing more than one plot, it's more elegant to use the axis. Okay, you can as well use the PLT, it doesn't matter, but I prefer this. It's more elegant to do this because you can easily, tweak the axis to your choice. You can add more axes, you can create more axis, you can create twin axis and all of that using by calling uh, using the axis, okay, to access each of the plots. So figure axis equals PLT of subplot. Then I set the title. I have two titles. You can see there I'm plotting 2 sine 2 pi t and 4 sine 2 pi t. This should be 2 pi t. Omit that, yeah, 2 pi t. And then next I'll do AX, I call the axis out of plot, the first plot, line width, and I'll set the label. Frequency is 1 hertz. Then I'll call the second plot. The frequency is 2 hertz, right? Frequency is 2 hertz. I think this should be 4 pi t, and here should be 4 pi t. Frequency is 2 hertz. Then I will now set the location of the legend by saying location upper right. You can have upper right, upper left, lower left, the bottom, middle. You can change the orientation where this legend is positioned. If you don't want know how which one to choose, you can as well still use best. So the Matplotlib automatically chooses the best location for you. Font size, frame on true. I would shed more light on this when I show the plot. And then I've commented out fancy box true, shadow true. We'll see that very shortly. So running this cell, we see what we have. So here I have the two plots. You can see that the blue plot is what the one has frequency, the first plot, and the white second one is this. So there's a lot you can do. Yeah, this. Also here you can set frame on to be false, and then you see what happens. Frame on to be false. Yeah, what happens is that this frame here in the legend will be removed. If I run this, what do we have? There is no frame on it. I always prefer this frame on to be false. Likewise, you can remove these. You can set fancy box to be true, shadow to be true. If we run this again, because we have set frame on to be false, you will not see this fancy and the shadow. So to see it, you have to set frame on to be true. Once it's true, and then we run the cell again, what do we have? You see there's a fancy box, there's a shadow to that fancy box. These are a lot of customization that you can do to your 2D multiple plots. With this, we have come to the end of this video. If there's any question you have or anything you want me to address in subsequent video, please leave it in the comment box. Like this video, share this video, subscribe to my YouTube channel if you have not done so. And then I will see you in my next video.